Hello, I am Nestor Arrespondo Jr. and I'm going to teach you about double integral. So before we discuss about double integral, it is good first that you should know the application of it in our real life. We use double integral in getting the area of a two-dimensional figure or getting the volume of an object under a surface. So like for example, we have here a cup. So the only given thing is the surface. So we can use double integral to get the volume of this one given the measurement or the points in the surface. So that's it. That is the application of a double integral. So let's define what is a double integral. It is a definite integral that can be extended to function of more than one variable. Before you proceed on this one, you should know already what is single integral. You should know already how to get the antiderivative of a function. So those are the prerequisites that you should know before you learn double integral. So consider, for example, a function of two variables z is equal to function of xy. The double integral of function xy is denoted as this one. The double integral of the function of xy dA, wherein dA is defined as dx dy or dy dx, and where R is the region of integration in the xy plane. So suppose we have a rectangular region, and the region is defined as x is greater than or less than a, and it is less than or equal to b, and also y is greater than or equal to c, and it is less than or equal to d. So where is that region? So if you're going to plot that, this is the region. We're going to get the volume of under this surface or region. So we can expand our formula into this one. Since we define dA as dx dy, so we can say the double integral of the function xy dx dy, or the double integral of the function xy dy dx. So let's have an example. Suppose we have the integral of x plus y squared dA, wherein the region is defined as x is greater than or equal to 0, and x is less than or equal to 1, and y is greater than or equal to negative 1, and it is also less than or equal to 2. So for you to better visualize it, we need to plot the different points. So we have here 0, 1, negative 1, and 2. So where do you think is that region? So let's extend the 1. So we have here, then negative 1, and then 2. So where do you think is the region? So we have here 0 also. So the region is here. Okay. Next one, we need to rewrite the equation. You know that dA, this one, is equal to dx or dx dy or dy dx. So we can rewrite the equation like this. So this will become the double integral of x plus y squared dx dy, or the double integral of x plus y squared dy dx. Okay, so there's a but here. So you need to remember that if you are going to start with dx, you need to put the value of x in this part or the innermost integral. So the value of x here is 0 and 1. And then dy, if you're going to make the dy become the last one, you need to put the value of y in the outermost integral. So this will become negative 1 and 2. And then, since you start with dy here, so the value of dy should be in this part, negative 1 and 2. And then dx, it will be on this part, 0 and 2. Okay? Did you understand? Okay. For this equation, or for this problem, what are you going to do? Is this, you need to start with dx first or dy first? For me, you need to start with dx. It is because the value of x, we have one of the value of x which is 0. So it is easier to solve. Okay. So we start with dx first. So we can rewrite the equation as the double integral of x plus y squared dx dy. Where are you going to put the value of d or of x, since we start with dx in or on this integral? So it will become 0 and 1, and then negative 1 and 2. So the first thing to do is to get the antiderivative of this one, or we get the antiderivative in terms of x. Okay, so let's start. So the integral of x plus y squared dx. We need to get the antiderivative of x plus y squared in terms of x. So what is the antiderivative of x? So it will become x raised to 2. Okay, so it will become 1/2 x raised to 2 plus, you need to get the antiderivative of y in terms of x, so you need to make y as constant. So it will become x times y squared. And what are the value of x? So 1 and 0. After that one, we are going to substitute. So it will become 1/2 times 1 raised to 2 plus 1 times y squared minus, okay, so what do you think is the value if you're going to substitute 0 on this equation? The answer is 0. So what will be the answer? So it will become 1/2 plus y squared. We are now going to substitute this value on this part. So it will become the integral of 1/2 plus y squared dy. And then we are going to get the antiderivative of this one in terms of y. So what is the antiderivative of 1/2 in terms of y? It will become 1/2 y plus, how about y squared? It will become 1/3 y raised to 3. What are the values of y? We have 2 and negative 1. So we are going to substitute 2 first. So 1/2 times 2 plus 1/3 times 2 raised to 3 minus 1/2 times negative 1 plus 1/3 times negative 1 raised to 3. So this equation will become 1 plus 8 over 3 minus negative 1/2 minus 1/3. If we are going to simplify it further, this will become 1 plus 8 over 3 is equal to 11 over 3 minus negative 5 over 6. The final answer will become 27 over 6. Can you simplify 27 over 6? Yes. They are both divisible by 3. So that will become 9 over 2. So the answer in our problem is 9 over